Today we're going to take a look at some solving basics for trig equations. And we'll do this working this problem, sine theta equals the square root 2 over 2. Now, if you're familiar with how we at Math Wilderness work exact value problems, you'll find that the method we use here for solving a basic trig equation has some similarities. It's almost working an exact value but in reverse, because instead of being given the sine of a specific angle and trying to find the value, we're given the value and the trig function, and we're working backward to find for which angle or angles is this going to be true. So a tip I like to think which angles have a sine of whatever value. So in this case, square root of 2 over 2. And just thinking that helps you have direction as you work through this method. So let's give it a try. Here's an outline. So first we'll analyze, we'll figure out which quadrants our angle answers should be in and what reference triangle and angle we're working with. And then step 2 will be actually stating our angle answers. So again, we're doing this for sine theta equals square root 2 over 2. So let's start our analysis. First, we want to find which quadrants our answers are going to be in. Which quadrants are we working in? Okay, so think ASTC, or all students take classes. This little acronym will help you remember which trig functions are positive in each quadrant. So work your way around from quadrant 1. The A goes in quadrant 1, S, T, C, so we're just working our way around. So what that tells us is all the trig functions are positive in quadrant 1, sine and its reciprocal cosecant are positive in 2. In quadrant 3, it's tangent and cotangent that are positive. And in quadrant 4, it's cosine and its reciprocal secant. And so you can see that we're working for sine of our angles should be a positive value, positive root 2 over 2. So we want to be in the two quadrants where sine is positive. So that's going to be here in quadrant 1 and here in quadrant 2. So let's go ahead and sketch those angles in. So approximately here and here are the terminal sides for our angle answers. And now we can move on to identifying our reference triangle. So we're just going to reference this triangle in the first quadrant, and then in step 2, we'll actually compute the angles. So we'll actually take that reference angle and find our final answers. So looking at the problem again, we want the sine of our angles to be square root of 2 over 2. So on the unit circle, recall our sine is going to be our y coordinate. So it's going to be our vertical triangle leg. And that should, seeing that root 2 over 2, that should trigger the 45, 45, 90 special right triangle in your mind. That's the one that has the two equal sides. It's an isosceles triangle. Okay, and we know that the central angle that goes with that, we've already said, is 45 degrees. So most of the time when solving trig equations, we'll be giving our answers in radians. But if you were giving in degrees, here you go. You've got your reference angle from this triangle, 45 degrees. Writing that in radians is also pretty easy. We know that's equivalent to pi over 4 radians. So now that we've done some analysis, we're ready for step 2, where we actually determine our angle answers. And again, we know these angles should be in quadrant 1 and quadrant 2 when we're considering just a single rotation or answers on the unit circle. Okay, so the one in quadrant 1 is easy enough because the reference angle is actually going to be our angle. It's just pi over 4. Okay, so let's go ahead and mark that answer. We know one of our answers on the unit circle is pi over 4. And then finding the angle in quadrant 2 is not too much more difficult. We know that the reference angle here, again, that's from x-axis to terminal side, that amount of rotation. So that we know is pi over 4. So basically we're trying to find this angle that I'll show in yellow. We're trying to find this angle. So to do that, recall that a half rotation is going to be pi radians of rotation, or you may want to write it so that it has a common denominator with the pi over 4 reference angle. Write it as 4 pi over 4. And so to find that angle that I sketched in yellow, you can just take away pi over 4, the reference angle, from pi. So 4 pi over 4 minus pi over 4, that's going to give us our angle that's in quadrant 2. That's 3 pi over 4. So these two angles are solutions to our equation. And you can, of course, plug them back in, double check If you calculate exact values, the sine of pi over 4 and the sine of 3 pi over 4 are both equal to square root of 2 over 2. So if you were just finding solutions from 0 to 2 pi or solutions on the unit circle, you're done. Now say you wanted to find or represent your solution so that it was for all solutions. So you want to write for all solutions. We do this clever thing where we write a solution equation for each of these two angles, so the quadrant 1 angle and the quadrant 2 angle. So let's start with the quadrant 1 angle, and pi over 4 is a solution, but all its coterminal angles, so if we add 2 pi or subtract 2 pi, all of those coterminal angles will also be solutions to this equation. So it's a really neat way to write it. You just say theta equals your original quadrant 1 angle, and then you say plus 2 pi k, or sometimes you'll see 2 pi n or some other variable. That variable is simply telling you that if you plug in an integer, then you'll get a different coterminal angle that will also be a solution to this equation. So that is one solution equation, and then we'll write for the solution equation in quadrant 2. So that's 3 pi over 4, and the same thing. So just add or take away rotations of 2 pi k, and that takes care of all the possible solutions. It's a really great way to represent infinitely many solutions. All right, so that's all there is to it. Hopefully this gives you a solid foundation so that you can move forward in solving more and more advanced trig equations. I'll post a link in the video description so that you have access to more worked examples for trig equations. And I also will post a link to a playlist that has unit circle basics. So if you need help with any of the skills that were involved in this method, you can check out those videos as well. Thanks for watching.